I'm Darren Meyer, and this is episode AI, the Phantom Dependency Menace, which is, of course, a pun because I love puns, and I love Star Wars. Hang a lantern on the kind of important things up front, which is I am sponsored to be here today. Endor Labs did send me. This content is based on research we did to improve our product. The advice contained here is not specific to our product. These are things you can do. This is not vendor specific, but it did come from our research, and they are paying me to be here, so I am going to be a little biased. So why me specifically? I'm an AppSec practitioner of a very long time. I've spent 20 years in the industry. I was a software developer before that. I was a logistics guy before that. I've been doing these things for a long time. My AppSec background includes practical research that I did for over 9 years, where I helped organizations figure out how to actually fix and avoid vulnerabilities in software. So I'm coming from having been on both sides of DevOps. Really? As we know, nothing ever goes smoothly, right? And of course, I'm a big general Star Wars nerd, right? So I'm very passionate about AppSec as a whole and about finding and fixing stuff, and about AppSec as an industry getting toward less detect and show and more help me actually get stuff done. The other question is, of course, what I mean by AI code. If I say, what's in your AI code, what does that actually mean to you? So imagine you have your cool new AI product that you've spent a lot of money to develop, or that you've hired an intern to do, one of the two. You have your code, right, that you've wrote to implement what you want to do. And along for the ride comes various libraries, things like TensorFlow, your model that you've picked, hopefully very carefully, and all the configurations that you put in place to avoid things like prompt injection and tune the model and behavior the way that you want to do. Given the time that we have today, I'm going to focus on libraries because it's one of the more overlooked aspects of LLM and AI security. Dependencies don't always work the way people think that they do. There's this idea that we just have a list of stuff and we just know inherently what the dependencies are, but package managers and runtimes, compilers, they're not very tightly coupled in most cases. I think the closest coupling I've seen is Go, which tries to do both together. But even that, like they're kind of ships passing in the night. They communicate through files. And the way this works from a development standpoint is developer creates a manifest file for their direct dependencies. The open source libraries they've gone out and picked and chosen, they stick them in their POM.xml, their package.json, whatever the case may be. And that's what the developer is going to care about. Then whatever build system you're using will run the package manager, your NPM, your Maven of the world, and download those direct dependencies, but also go through a tree resolution process where it's finding out what are the dependencies of my dependencies. We call those transitives, right? And all it really does with those things is put them on the file system, right? It's just a directory of files at the end of the day. Sometimes there's complicated things like cache managers, but at the end of the day, it's files on disk and in a location or set of locations that's predictable. And then your runtime or your compiler loads those from disk because it needs them, right? That's really all there is to package managers. But there's a little bit of a disconnect because the package management and the runtime or the compiler work at different times, right? And so things get out of sync. Just out of curiosity, how many people heard this slide as soon as they saw Palpatine up here? Right? It is unavoidable, right? It does, it happens. And it happens in a few different ways. As a developer, I might import a new dependency and not update the manifest file. I pipt installed, I forgot to put it in my Pi project, right? Sometimes I'm going to depend on those dependencies already being there in my deployment environment, right? If I'm deploying on Linux, I might use the Linux package manager to deploy a bunch of Python modules, and I go, well, I don't need to put those in my manifest because I can trust they're going to be there in my container or on the server I'm deploying to, so why do I need to specify them, right? And then, of course, on the flip side, sometimes I have things that I've said, this is a test-only dependency. I don't want it to go to production, but I got lazy and I started using it for production purposes because it has conveniences. Anybody familiar with JavaScript's Storybook? Yeah, okay. So I've seen many, many times, because Storybook has a lot of useful stuff in it, people start using little features of it for the production code, and then you got to ship this huge dependency that was really only meant for testing. Sometimes, like I'm a developer too, I get lazy. I forget to remove stuff. I stopped using the dependency, I adopted something else, a replacement. I put the new replacement in my manifest, but I didn't clean out the old stuff. And now I'm shipping that thing to production every time, even though I'm not using it at all. So the reality of what I'm using, what I'm loading, what I'm actually calling functions inside of changes over time and doesn't necessarily sync up with what I have in my manifest file, because from a developer standpoint, if it works, I'm not going to touch it, right? My test pass, we're good. The end result of this is your manifest itself can actually lie to you. And I know this is a little bit of an eye test, and I'm sorry. This is the page for OpenAI's baselines library. And I wanted to point out the thing that it does, which is, hey, just pip install your dependencies. Right? We see this with a lot of AI things because they're not necessarily catering to advanced software engineers. A lot of people using these AI things are not developers as a primary function. They've sort of learned to code. They're doing something else. They're data scientists. They're product managers. They're junior developers who are experimenting with things, right? So this is the easiest way to get them going. And in the case of baselines, it's not going to function without the right version of TensorFlow. And the right version can be a number of things. It's not just like a version number difference. There's also variants. There's like a GPU-optimized version and a CPU-optimized version. In some cases, you might have to get it for the right platform. Like if you're going to run this on ARM, you need an ARM variant, right? So as a developer, unless I'm a fairly advanced software engineer and I know how the package manager works, I'm probably not going to put this in my manifest file at all because it's annoying, right? Instead of putting every variant in, I'm going to just trust the deploy script to take care of it for me. And this isn't just OpenAI, right? Like, you're not going to show up in a manifest or a lock file as a result of that, and that means that your tools aren't going to see it. Like most SCA, or if you're using some kind of dependency tree manager, anything like that, it's just not going to see it. It's completely invisible, right? And Mistral does this, right? This is all over Hugging Face, right? You go and look at model things. They always pip install some stuff, and then go on. They sort of just trust you that you should put it in your manifest file and trust you to know that. But we don't see that in the wild. We see a lot of people just following these instructions and shipping it to production. Okay. So how bad of a problem is this? We got 15 of our customers to volunteer their code bases to analyze this because we knew this was probably a problem, but we didn't know the scope and scale of it. And as you can see, almost everybody has at least some of these phantom dependencies, right? These things that are installed that the code depends on, but they're not in my manifest file and they're not in the transitive tree either. Right? But it doesn't cause a lot of problems. It kind of paces the number of vulnerabilities I get, kind of pace the number of deps I have, small percentages, and then it kind of explodes down here. Anyone want to guess what the difference is with those last 3 customers? It's lots of AI code, right? These are people who've gone big on AI code. They have a lot of it in their environment. They're deploying a lot of it to production. And you can see, like, in certain cases, over half the vulnerabilities are in these phantom dependencies that are completely invisible to most of the security controlling tools that are designed to detect them, right? So it is a problem, but it's been a problem we've largely ignored as an industry, but we can't anymore because the changes in engineering practice around how AI is developed in the real world are leading to a bigger problem, right? And when I say changes in engineering practice, I'm talking about things like, hey, I'm just going to assume these dependencies are provided by the system or are downloaded by me as part of this deployment, right? I'm still deploying things with shell scripts and manual actions. It happens more than you would like to think, right? I'm just using scripts or pre-built containers as my deployment. I'm trusting those things entirely. Or I have variants that depend on the target platform, right? So I might deploy this application to some ARM servers, to some GPU-based servers, right, to some standard x86 servers. I have different variants, so I'm punting it to the ops team, and it's the classic, I'm just a developer. This is an ops problem, right? When we find a lot of these things, AI code's not going through DevOps processes, right? So these companies all have DevOps teams who've said we don't want to touch this, or where they have advanced technology teams or AI teams that are allowed to go and bypass those DevOps processes. So they've kind of gone back to this old, like, it's an ops problem now, right? Which is what leads to this kind of problem. And of course, that poses certain security challenges. You get a false sense of security, for one, right? So if I have all my tools in place, I find out these guys are writing some AI code, I'm like, you got to run this scanner in here, you got to put an SCA tool in, at minimum you got to run dep check, something, right? And it comes back clean. Great, except it didn't see half my dependencies because they weren't in the manifest, right? If I'm compliance-oriented, and any of this stuff is in compliance scope, You are required by most regulations and contracts that care about software security at all to have an accurate software inventory of some kind. In some cases, it's literally produce an SBOM to prove it. But in all cases, they're like, you have to know what software you have. Well, guess what? If you're relying on dependency tree tools of any kind, including SCA tools, and they don't understand this thing, you now have a compliance gap. Fortunately for us, auditors aren't very savvy to this yet. But I have had a customer in one case where their auditor was like, we can't trust your tool at all now because it didn't see these things, and we did a spot check, and we found out you were using something that wasn't in your manifest, wasn't in your SBOM. So now you're in trouble. Now you have a big audit finding to close across thousands of projects because you got to go and prove that you have visibility to these things, which is a manual process, right? And of course, the last one that always bites everybody, dev and prod can vary. Most of the kind of controls that we do for vulnerabilities in dependencies and things like that, they're run in dev, they're run in CI. We're trying to get out, we've shifted left, right? And we're trying to get out in front of these things before they go to production. But if you're relying on a container or a build or run environment to provide certain things, you need to do an extra step to make sure you don't have differences. Is the container that I'm using for my CI runner going to match the container that I'm deploying to production? How do I know? So there's an extra control you have to put in place to make sure that those things are the same and you're comparing apples to apples. Otherwise, you can end up with, well, yeah, the dev one's got, up to date, but the production one hasn't been updated in a year, right? And the end result of this is because most tools are blind to this entire category of problem, and they're blind for very specific reasons, and it's because most of the things in this space have trusted the manifest, right? And if you go scan the open source world, this is a reasonable thing to do, right? And anybody who builds security tools for software security, you start with the open source world because you've got tons of code available. And I look at them going, manifests are pretty reasonable reflections of reality. The build systems are very clean, so I'm going to trust that. That seems to get me 90+% accuracy. We're good. But it turns out that we know that the manifest can lie. When you get into the real world, you bump into that problem. Not everybody's come up with a solution. So not only do you get the phantom dependencies that we're talking about, those things that are brought in by the system and all of that, and that's a false negative problem. You also get misused dependencies, right? That's that test dev problem. That's another false negative problem. It can also be a false positive in some cases because you might report on something that's flagged as test, which, I mean, technically I have it, but if I know it's not going to production, I don't have a production risk, right? So it can be false positive in that way as well. And you can get like unreliable fixing patterns, right? So this is the case where I brought in a dependency, it brings in a very useful transitive dependency, and I go, I'm gonna start using that as if it were direct. And there's this sort of security assumption when we're prioritizing things where we look and we say, the further away from my code a vulnerability is, so if it's in 4 layers deep in a transitive of a transitive of a transitive, the less likely it is that it affects my code. It's not 0, but the chances go down. So a lot of organizations use that for prioritization. They say, look, if it's more than 3 levels deep, we're going to choose to just accept the risk. But if I now am using it like it's a direct dependency, that assumption is now bad. Right? And my tool can't tell me that because it doesn't understand how I'm using it. It's just looking at it's in the manifest and its relationship. Right? And then, of course, the last thing is we talked earlier about unused dependencies. That's a false positive problem and a noise problem because it's going to report vulnerabilities in a thing I'm not even using. And that's going to look like I have risk, but in fact, I don't. It's just a dependency sitting on disk. Right? And that's a library sitting on disk that nobody's using doesn't really pose any meaningful risk. Right? So what do we do about this? The answer turns out to be deceptively simple. Program analysis solves this problem, right? So instead of just having a tool look at a manifest file and say, what do I have? You say, let me look at what the code is actually using. What do I mean by actually using? Actual use is the code, whether that's the source code or the bytecode. That tells me what I'm really loading and what I'm really using. And not just loading, but what am I calling, right? And so program analysis, I can analyze the code. I can create an abstract syntax tree, right, or some other representation. And then I can look at the types and call flows through that and determine, hey, do I have a chain from something I wrote to something that's in that dependency? Now I have a real dependency graph. I know what I'm using. Right? This is sort of like the world's simplest version of reachability. Right? Once I have that call graph, I can ask it all kinds of questions about what I'm using, where, and how I'm using it. And that includes my ability now to correlate dependency graphs with other information I have about dependencies. So once I have the call graph, the question I'm basically asking it is, hey, I have this list of dependencies that I see on disk that are defined by the package manager. I've looked at the manifest file. I've looked at what's in the package manager caches and all these things. I know what dependencies potentially exist. And I can compare them to the call graph to say, OK, what's actually being loaded? And when I can unify that into a single view, I get information about what am I using and what's relevant to the application that I wrote, regardless of whether it was declared in the manifest. And I can get information about, was it declared in the manifest and a direct dependency? Is it the child of something that was declared in the manifest? Was it undeclared in the manifest, a phantom dependency, and so on? And I also get, for free, I get what am I not using, right? So I can now have a unified view that includes, hey, I see that you've asked for a dependency, but it's not actually in use anywhere. You're shipping dead code, right? Which has this nice long tail of cost. If you're shipping dead code, you're downloading it every time you build. You're shipping it around. It's half a cent. But if you're doing it thousands and thousands of times, that adds up, right? So there's a cost to having unused code. I'm going to use Python as an example now. Quick pause. Every other illustration I've had has been Star Wars related. This one is too. Anyone know why? This is a stormtrooper phase ball Python. I told you there'd be puns. So in Python, we're going to probably use source code. The binary representation is kind of a moving target. So we're going to look at imports of dependencies in the source, right? OK, it was imported, so maybe it's used. Then I'm going to compare that import to a call graph and say, was it actually used? Right, I loaded the symbols. Did I actually call them anywhere along the way? I'm going to have to repeat that over and over and over again all the way down the dependency tree. Right? So now I have a complete dependency graph. Does that make sense? Okay. Then I'm going to take that dependency graph, and I'm going to look at the versions installed. I'm going to look in the virtual environment. I'm going to look at the system-wide Python cache. I'm going to look at any system-installed libraries that might be relevant. Right? I'm going to look at all those kind of defined locations based on the Python environment that I'm seeing. And I'm going to look at the manifests that are provided with the project. And now I've built a list of potential dependencies. And then I'm going to correlate and unify those results. So I'm going to take the intersection, right? I'm going to have all of the things that I see are being used, all of the things that are declared, all of the things that are actually on disk, and find out where's that intersection, what am I actually using, and what was missing from which thing, right? Ideally, if you are following proper software engineering, you should be in all three categories. So it's interesting to me to be able to find out the ones that are missing one category or another, right? And of course, as a side effect of this, you get accuracy in your SBOM and in your VEX if you're using that. So for those who don't know, VEX is the vulnerability exploitability exchange. If you're generating SBOMs, you should be generating VEX too, because it lets you communicate with your downstream providers about, I've seen these vulnerabilities and I've annotated what I'm going to do about them. Right? So it lets you say things like, I'm accepting this risk. Saves tons of time when talking to auditors. It's great. So that's kind of the problem in a nutshell. Right? We have a problem with AI in that it's particularly susceptible to this phantom dependency problem. To solve that problem, we're using program analysis, and that gets you a few things for free, including SBOM accuracy, VEX accuracy, and information about things like unused dependencies. It also gets you more accurate information about your risks, right? Because if I have a vulnerability reported in something I'm not using, guess what? That's not real. Taken to an extreme, you also get function level reachability. So if you have a full call graph and you know where the vulnerable function is in the dependency, you can also get information about whether that vulnerability actually impacts your code, whether it's loaded, but does it impact my code? And that's kind of the next level of reachability that happens, but a little bit out of scope for this conversation. I want to quickly thank my colleagues who helped with this. There's been a ton of open source projects and research. I couldn't possibly list it all. It would be pages and pages and pages of things that were valuable and helped in this research. My colleagues, Dimitri and Henrik, have done a ton of work, not only developing program analysis that helped us kind of understand this problem, but also doing a lot of the original research that helped us understand that it existed and the scope and scale and why. And to Jamie Scott, who's one of our product managers, who helped me with data models and reviewing content, making sure I wasn't saying anything silly. My QR codes are safe for all purposes, trust me. My Mastodon and my LinkedIn are best ways to talk with me. I would love to continue to talk with you on SAA topics, CPSS, AI and how it affects supply chain security. All those things are passions of mine. Does anybody have any questions? I've tried to leave some time. Sure. So the question was deployment models. Different tools take different ways of doing this. For our tool, for example, you actually have a choice of shipping your project off to us and having it done on the cloud, or having it done inside your CI, and the cloud components just have data. Other vendors take different approaches. Some do it entirely inside walls. That's the approach that OS Depcheck has taken, for example, to be entirely contained in CI. Some are entirely cloud solutions, and Veracode is probably the most well-known of those, where you ship it off to them and they do the analysis and send you the results. So you have options depending on which tool fits your needs. I'm sorry? No. This is an approach. We're not the only one who can do this. We were the kind of the first to do it, but other people have solutions to this. So like I said, it's really not tool specific, and I'm biased. I think ours is the best, right? But it's not going to fit for everybody. So.
Maybe somewhat related question. Are there any open source tools out there that can create those dependency graphs you were talking about, for instance, for Python projects, or is this one necessary?
OWASP Depcheck has the beginnings of it for a couple of languages. They aren't really using it in this way, but the underlying stuff is there. So it's an opportunity for people who are passionate about this kind of thing. If you want to contribute, that'd be a great project to contribute that to, because they do have a degree of reachability analysis that can tell you what's used. It wouldn't take much to get them there to do on a one-off project. For languages where they have it, there's Java and 2 others. Sorry? OWASP has a thing called dependency check, Depcheck for short.
So to add to that, you can do it for Jorn, JORN, white.ai. They have to call Jorn, it's open source, does the same thing, and it's telling us both compile and run. But my question was that, so at any point, static analysis is never dependency. There are non-deterministic components of static analysis, right? So for example, there's a token in a language which you might not recognize, even though it is a reference. Say for example, a Rust pointer versus a C pointer. Just simple. Now, these bring in the issue of confidence.
Mm-hmm.
That is, even though I feel this is a path to a vulnerable component, it might not be. Or I might, guess some path that was typically not valid, right?
Mm-hmm.
So the issue of confidence comes in. Do you bring in a probability with your reachability to say that I am X% sure that this is a reachable component or not?
We do above the line, below the line. So one of the ways we saw, and you're right, by the way, for all static analysis is imperfect. Has to be. The person who solves that is going to win a Nobel Prize, right? That's a really hard problem. What we try to do is we look at it and we say, and I think this is important if you're doing any kind of static analysis, especially for security, is to have the yes, no, maybe, rather than just yes or no. And those differences are, I have high confidence that it is, I have high confidence that it's not, or I couldn't make a determination. And from a security practitioner standpoint, you need to know which of those things I couldn't make a determination, because those are the things that require human analysis. What we found is, depending on technique, you can get that down to between 5 and 10% of your total call graph paths across projects. Different languages, different projects, different techniques have different degrees of confidence, but you can generally get it down to 5% of the things that you have to look at and say, these are the things we just couldn't get to a high confidence with. And even though the things that are high confidence, there's always going to be a little bit of false positive, a little bit of false negative. It's not avoidable, unfortunately. Did that answer your question?
Maybe outside, but my actual, that does answer to significantly, but my actual concern is what is high confidence?
I'm sorry, say again?
My actual concern is what is high confidence? What is the threshold that I'm looking for?
And I don't know off the top of my head, I'm sorry. Yeah, I would have to ask our research team for that. Anyone else? All right. Thank you very much for spending time with me.